Dear children, hearty welcome to today's class. Today, we are going to see a new chapter, liquid state. And here, we are dealing with the introduction to liquid state. As we know, liquids are one of the states of matter and the other states are solids and gases. When we look into liquids, there the molecular arrangement of molecules are not that much tightly packed like solids. In solids, they are tightly packed. But in the case of gases, the molecules are arranged randomly. Here, if you see here we can see the molecular arrangement. Here, in the case of solids, the molecules are arranged closely packed. There is not that much empty space. There is no empty space between them. But in the case of liquids, there is empty space between two molecules. Here there is an empty space, here also empty space. So when you look into liquids, there is empty space between the molecules in the liquid state. If we see here the molecules are arranged randomly. There are lot of space in between. In the case of liquids, because of this empty space and the liquids are incompressible. There are only very little empty space compared to gases. So we know that gases are compressible, but solids and liquids are incompressible. Because of the molecular arrangement, the solids and liquids are incompressible. Then, because of this molecular arrangement, there is an attraction and repulsive forces here in the case of liquids. Then, because of this intermolecular attraction and repulsive forces, and especially because of the attractive forces, the liquids can have a definite volume. We know that if we see here, the molecular arrangement of liquids are like this. Here there is a lot of empty space between each molecules, and when we look into liquids, there is a surface. But if we look into gases, there is a lot of space between the molecules and there is no surface. If we pour a gas in a bottle, there the bottle fully the gas will occupy. But in the case of liquids, if we pour water in a bottle, there will be a space. The water can occupy according to the shape of the container. That means if we pour liquid or water in a bottle, it occupies the shape of the bottle, and if we pour that water in any beaker, it occupies the shape of the beaker. So all these properties are because of the molecular arrangement of liquids, and liquids are much more difficult to compress than gases. Then, because of this molecular arrangement, the density of liquids are lesser than that of solids. That means density is mass by volume. Here, in the case of liquids, the number of molecules per unit volume is less. Therefore, the liquids are much more denser than gases. But the density of solids are more high because the molecular arrangement, in the unit volume there are more molecules. Since there are more molecules, the volume also high. Therefore, the density of solids are high compared to liquids. But in the case of liquids, the density is lesser than that of gases. Here, if we list out the properties of liquids, they are, in the case of liquids, there are more attractive forces between molecules in a liquid, and the liquids, the molecules are closely packed together, but it is not that much like solids. They are having some empty space between them. And the third property is the average kinetic energy of liquids are a function of temperature. That means the kinetic energy Ke is a function of temperature. And the fourth property is liquids are denser than gases. That means the unit volume, there are more number of molecules in the case of liquids than gases. The fifth property is diffusion of liquids is slower than that of gases. That means in the case of liquids, the mixing is very difficult than the gases. In the case of gases, it is easy to mix, but in the case of liquids, it is difficult to mix. Therefore, we can say that the diffusion of liquids is lower than that of gases. So, here are the properties of liquids. Next, we move on to the next topic, that is characteristics of liquids. The important characteristics of liquids are fluidity, cohesion, viscosity, boiling point, surface tension, etc. So, now let us see all these characteristics of liquids one by one. All these characteristics of liquids are due to the special molecular arrangement of atoms in liquids. Here, if we look into the first characteristic, that is fluidity. Fluidity is nothing but the property to flow. Liquids can flow, but gases cannot flow like liquids. And another property of liquid is that it can occupy the shape of the container. That means, as I said earlier, if we pour liquid into a bottle, it occupies the shape of that bottle, and if we pour liquid in a beaker, it occupies the shape of that beaker, and if we pour liquid in any vessel, it can occupy that particular vessel shape also. The next characteristic is cohesion. Because of this molecular arrangement and there is little more empty space and all, the liquids are having strong intermolecular forces between them. But it is not that like solids. In the case of solids, the intermolecular attraction forces are strong, but in the gases, there is the intermolecular attractive forces are negligible compared to solids and liquids. In the case of liquids, it is in between solids and gases. So, because of that, it shows the property of cohesion. Next is surface tension. Here, if we look into the molecular arrangement of liquids, here the molecules are arranged like this, and here if we consider this molecule is having an attraction from all the sides. But if you look into the surface molecule, here this molecule is having an attraction from this side only. Here there is no molecule, therefore it is not having an attraction from the upside, only from this side it is having an attraction. So, because of that, the surface molecules are pulling towards the interior. Because of this pull, there will be a tension on the surface. That is called it as surface tension. So, the surface tension is one of the properties of liquid. Next is viscosity. Viscosity is nothing but the tendency to resist the flow of the liquid. That is because of the friction between molecules. So, we are familiar with the honey, then oil and all. So, in the case of this honey and oil, it is having little bit difficulty to pour than the water. That means if we pour water from one container to the another container, we can pour it very easily. But if we pour this honey or oil, there is some difficulty to pour this liquid to another container. That is because of the viscosity. Next we have another characteristic, that is boiling point. Boiling point of the liquid is the temperature at which the vapor pressure of the liquid is equal to the atmospheric pressure. The vapor pressure of the liquid, the temperature at which the vapor pressure of the liquid is equal to the atmospheric pressure. So, these are the different characteristics of liquids. The important characteristics are fluidity, cohesion, viscosity, surface tension and boiling point. All these things we will see in our upcoming modules in detail. Here only we are giving an introduction. Next we are going to see the different types of liquids. The different types of liquids are polar liquids, non-polar liquids and ionic liquids. The polar liquids, as the name says, these liquids are polar, and non-polar liquids means the liquids are non-polar, and ionic liquid means the liquids will be in liquids there will be ions. Okay, so if we see these types of liquids in detail, polar liquids have a permanent electric dipole moment. Permanent electric dipole moment. Dipole moment is nothing but the separation of charges. That means here we have the polar liquids examples, water and ammonia. So, how this water and ammonia become polar liquids, that we will see now. If we look water, here there is a separation of charges. That means here the oxygen is highly electronegative compared to hydrogen. Therefore, it is having a partial negative charge, and this hydrogen is having partial positive charge, and this hydrogen is getting a partial positive charge. So, because of this separation of charges, it is having a dipole, and this dipole is not cancelling also. Therefore, water can exist as a polar liquid. Our next example is ammonia. When we look into ammonia, here the structure of ammonia is like this. Okay. Here the nitrogen is electronegative. Here because of that this nitrogen is getting a partial negative charge, and this hydrogen is getting partial positive charge, this hydrogen is getting partial positive charge, and this hydrogen is getting partial positive charge. And here also there is a separation of charges, and these charges are not cancelling each other. Therefore, ammonia also a polar liquid. I hope you understood the polar liquids. Next, we are going to see non-polar liquids. As I said earlier, the non-polar liquids do not have a permanent dipole moment. That means the dipole moment will be 0. If we see the examples like carbon dioxide, here in the case of carbon dioxide, this oxygen is having partial negative charge, both the oxygens, and this carbon is having partial positive charge. Okay, so but here in the case of carbon dioxide is having a linear structure. Because of this linear structure, these dipole moments are cancelling each other, and the dipole moment will be 0. That is why carbon dioxide is existing as a non-polar liquid. Then our next example is oxygen. In the case of oxygen, here we have this, here also this oxygen is having partial negative charge, this oxygen is having partial negative charge, but because of this oxygen is existing as a non-polar liquids. Then here we have ammonia, here we have methane gas. Methane is having a tetrahedral structure, and here we have one hydrogen, and here we have one hydrogen, here we have one hydrogen, and here we have one hydrogen. And this carbon is having a partial negative charge, because compared to hydrogen, this carbon is electronegative, and this hydrogen is having partial positive charge, and this hydrogen is having partial positive charge, and this hydrogen is having partial positive charge, and this hydrogen is having partial positive charge. In the case of methane, what happened means the charges are cancelling each other. Here this CH bond and this CH dipole moment are cancelling each other, and this CH and this CH are cancelling, mutually cancel each other. Therefore, the dipole moment is 0. Therefore, this methane gas can exist as a non-polar liquid. Next type is ionic liquids. Ionic liquids are composed of ions, often used as solvents and electrolytes. The examples are pyridinium and imidazolium. So, pyridinium, if you look, the structure is like this. So, this is pyridinium, there is an ion. So, these ionic liquids are composed of ions. This pyridinium is composed of an NH plus ion. And imidazolium. So, this is the imidazolium, liquid imidazolium. Here they are also the NH plus ions. So, these are examples of the pyridinium and imidazolium are some of the examples of ionic liquids. So, here we saw that what are the types of different types of liquids. They are polar liquids, non-polar liquids and ionic liquids. Next, we are going to see the intermolecular forces in liquids. There are different types of intermolecular forces. One is hydrogen bonding, second one is dipole-dipole forces, and third one is London dispersion forces. Now, let us see one by one. Hydrogen bonding is nothing but the interaction between molecules with hydrogen atoms bonded to highly electronegative atoms. That means, if we take the example of water, here we have water. This oxygen is bonded to the hydrogen of another water molecule. So, here one water molecule is there, the oxygen of this water molecule is bonded to the hydrogen atom of the another molecule. This is the example of hydrogen bonding. Hydrogen bonding is nothing but the interaction between the molecules of hydrogen with the strongly electronegative atom. Here the oxygen is an electronegative compared to hydrogen. So, this oxygen, highly electronegative oxygen, is having an attraction towards this hydrogen. This is what the hydrogen bonding comes. Then we have dipole-dipole interactions. Dipole-dipole interactions means it is something related to the interaction between the two polar molecules. That means, if we take an example of HCl, the separation of charges, this hydrogen is having partial positive charge and this chlorine is having partial negative charge, and this chlorine is attached to hydrogen. Okay. This is the dipole-dipole interactions. So, these dipole-dipole interactions are also present in the case of liquids. Next is London dispersion forces. London dispersion forces are the forces between the two nonpolar molecules. Nonpolar molecules means they are not having any separation of charges. That means if we take a molecule like this is, suppose this is a nonpolar molecule and we have another nonpolar molecule here, and we know that these molecules are in motion. At particular time, these molecules are getting the separation of charges. That means in one side it is getting a partial negative charge and in the another side it is getting a partial positive charge. And here we are inducing a dipole moment. That means we can say that this nonpolar molecule now has become an induced dipole moment molecule. Okay. Here this nonpolar molecule has become a polar molecule now because of inducing the dipole, because of the motion of constant motion of this molecule. Now what will happen when some another nonpolar molecule is come in contact with this molecule? The electron cloud of this nonpolar molecule is getting distorted by the attraction of this induced dipole molecule. Because of this attraction of this induced dipole molecule, this also getting some separation of charges, and because of that there is some attraction is getting here. That is what the London dispersion forces. Therefore, the intermolecular forces in liquids are 3: hydrogen bonding, dipole-dipole interactions, London dispersion forces. Now, let us see some of the applications of liquids. We know that in daily life we are coming across with different liquids, and these liquids are having some applications in our life. They can be used as a lubricant. That means for lubrication some liquids are using. To reduce the friction in the engines we are using liquids. And another application is solvation. That means some liquids are using as a solvent. Then another application is cooling. Another application is cooling. Cooling means all liquids are having a tendency to change into a vapor state. So once it change into a vapor state, automatically the other molecules in the liquid state is having the energy will reduce and there will be a feeling of cooling. So these liquids are having an application of cooling. Then we are using liquids for cooking and for distillation. That means because of the different boiling points of liquids, we can separate the liquids from the mixtures. So these are the applications. They are liquids can be used as a lubricant and they can also use as a solvent, and liquids are used for cooling. Liquids are used for cooking in our day-to-day life, and lastly liquids can be used for distillation. That means we can separate liquids from the mixtures of liquids because of the different boiling points of liquids. Now, these liquids are having some of the applications, or they are playing a vital role in our body also. We know that blood, that is a liquid, that can be used as a nutrient, that is used for the transport of nutrient and oxygen in our body. And one of the important liquid is water. It is used for the waste removal of our body. And another thing is temperature regulation. To regulate the body temperature, the liquids are using in our body. Another application is for organ protection. We know that our brain and spinal cord are very sensitive tissues. They are protecting by the liquids or fluids in our body. Another application is liquids are used for the digestion and absorption of food. That is digestion and absorption of food. Lastly, these liquids, especially water, is a fundamental component of cells, tissues and organs, and this water is necessary for the proper functioning of our body. Therefore, the applications are, first thing is nutrient and oxygen transport, second one is waste removal, third one is temperature regulation, fourth one is organ protection, fifth is digestion and absorption, lastly we have the cellular function. Okay, I hope you understood all these things. Here as an introduction we saw that the molecular arrangement there, because of all these properties of liquids are due to the special molecular arrangement. That means the liquids are having the molecules are arranged like this and there is little empty space between the liquids, but in the case of solids they are closely packed. In the case of gases the molecules are arranged randomly. This is the special molecular arrangement. Because of this molecular arrangement, liquids are incompressible than gases and they are more denser under normal conditions, and the different properties, it can have different properties like viscosity, then surface tension, cohesion, fluidity, and the special thing is that the liquids can have the shape of the container it occupy. Then when we look into the different types of liquids, they are polar liquids, non-polar liquids and ionic liquids, and the intermolecular forces in liquids are hydrogen bonding, dipole-dipole interactions, London dispersion forces, and finally we saw that the different applications of liquids, they are lubrication, solvation, cooling, cooking and distillation. And we saw that the important functions, the vital role of liquids in our body. So, when we look into all these things, what we can understand that the liquids are one of the states of matter which has one of the essential state of matter with unique properties, and because of these unique properties, types and intermolecular forces of liquids, it has a crucial role in chemistry and related fields, especially in material science. Now we wind up this session here, and in the upcoming sessions we will deal more with the characteristics of liquids, types of liquids and all this importance of liquids. Thank you.